Bismillahirrahmanirrahim. Assalamualaikum and a very good day to everyone. So today we will continue our new chapter, which is chapter 4, that is regarding on the Laplace transform. So these are the outlines that we will cover in this chapter, which is we will briefly go to the introductions of the chapter, the definition of the Laplace transform, the inverse of Laplace transform, the properties of Laplace transform, and lastly the circuit analysis or the applications of the Laplace transform. Alright, now let's look at the concept of Laplace transform. So basically, when we have a time domain equation, there is a classical solution to solve the time domain solution. Yeah. So basically, the classical solution involving of differentiation and integration. Alright. So there's another method that we can use to solve this time domain equation. Alright, if you can still remember, in our previous chapter 3, we have solved the time domain equation using the Fourier transform. Yeah, but now in chapter 4, we would like to solve the time domain equation by using the Laplace transform, where we will convert the time domain equation into S domain equation. Yeah, so S domain equation basically has a j omega, j omega, and then we will do the algebraic manipulation, and we solve the S domain equation, and then we will convert back the S domain equation into the time domain equation by using the inverse Laplace transform, right? Okay, so this is the process of Laplace transform. Okay, if this is the process of Laplace transform, right. So first of all, we will convert the time domain into the S domain function. All right, and then we will solve the S domain function based on the Laplace transform properties. So the properties we can refer to the table, to your appendix, and then we will reconvert the S domain function into T domain, all right, by using the inverse Laplace, and finally we will get the final output. Final output. Okay, so before we go further into Laplace, the discussion of Laplace, let's see what are the importance of Laplace transform, or where can we apply the Laplace transform. Okay, so in engineering, Laplace transform is used to solve a complex differential equations, okay, that is used to model an engineering system. And we also use this Laplace transform to generate the transfer function, okay, where the transfer function will represent the system such as electrical circuit and the control system. So the transfer function also will representation gives an algebraic relation between the Laplace and transform of the input and output of a system, right? So these are the application or the importance of Laplace transform. Okay, now let's look into the time domain function. So usually you have familiar this time domain function with our previous chapter. Okay, so time domain function is an equation or an expression that relates with time. Okay, that relates with variable of time. So a change in time will cause a change in certain variable. For example, if we can look at this equation, so these are the output and these are the inputs. So of course, when the time here is changed, the value of 2t also will change, and as a result, the output also will gonna be changed. So the change of time will change in certain variable, and of course the output also will gonna be changed as well according to the time. Alright, so now this is the example of the differential equations in time domain forms. So at this part, this is the input and the output is equals to 3t for this equation. And for this equation, at this side, our left hand side, this is the input and the output is equals to RT. Okay, let's say if the output RT here, or the output here, yeah, if the output is equals to 0, okay, if the output is equals to 0, we call this particular equation as a homogeneous equation, yeah, as a homogeneous equation. However, if the if the output is not equals to 0, let's say the RT now is not equals to 0, so we call that particular equation to be an inhomogeneous, yeah, inhomogeneous, which is the opposite of it, yeah? Inhomogeneous equation. All right, so if the output is equals to 0, it is known as homogeneous equation. If the output is not equals to 0, it is called as inhomogeneous equation. Okay, now let's look at the first principle of Laplace transform. Yeah, so these are the first principle of Laplace transform. Okay, let's look at this. For example, you have a time domain equation. All right, when you have a time domain equation and we want to solve this by using the first principle of Laplace transform, so what we have to do is we need to convert from the time domain into the S domain. So now instead from the small letter of V, because it is in the time domain, it will now change into the capital letter of V, because now it is in a S domain. So same as what we have learned in our chapter 3, yeah, in our Fourier transform, right? So in Laplace transform, it will become, instead of V omega, if in our chapter 3 we're going to be V omega, however in our Laplace transform it will become Vs, yeah. So Vs is equals to Laplace of Vt. So Laplace of Vt can be written as integrations from 0 until infinity, meaning that the process or the equation must be in a positive region. Okay, must be in a positive region where the t must be larger or equals to 0. Yeah, must be larger or equals to 0. So based on the equation, and you need to multiply with exponential of negative st dt. Alright, so this is from the time domain we want to convert into S domain. So these are the process, yeah, these are the process where we involve the process of integrations from 0 until infinity. The equation then will be multiplied with exponential negative st and dt. Alright, and then let's say we want to we want to inverse from the S domain into the time domain back. We want to change from the S domain now back into the time domain. All right, so what we have to do, we need to involve the second principle, which is the inverse of the Laplace transform. So inverse of the Laplace transform, so we will obtain again back the time domain. So how to do that? It will be the inverse process of the S domain equation. So the inverse of the S domain equation is equals to 1 over 2 pi j. Okay, this is constant, yeah. 1 over 2 pi j integrations from negative j infinity to j infinity. So the Vs equation, and you have to multiply with exponential st ds. Alright, so after you undergo this equation, then you will get again back to the time domain equation, yeah. Alright, now let's look the definitions of Laplace transform. So the definitions of Laplace transform is if the equations in a time domain function, yeah, where the time is larger or equals to 0, its S domain function fs can be obtained by this equation, by this equation, where we are make the from the time domain, we Laplace the Laplace of time domain is by integration from 0 until infinity for the ft equation, and then we multiply with the exponential of negative st dt. So the L here, so the L here, okay, the symbol of L here is known as Laplace operator. Okay, this is known as Laplace operator. Okay, now let's look in some example. So given ft is equals to 1, where the t must be in a positive value, which is t, the range is larger or equals to 0, and we need to find the function of ft in S domain. Alright, so the solution, okay, we're going to use this first principle, this first principle of Laplace, where from the equation given ft is equals to 1, and so in order to convert from the time domain into the S domain, now we need to use the Laplace first principle, Laplace first principle, whereby the principle state to us where we need to do the integrations, which is from 0 to infinity, so the equations of it, and multiply with exponential negative st and differentiate of dt. So in this case, since the ft is equals to 1, therefore this is equals to 1, and this is actually have 1 in front here, so left behind 1 multiply with exponential negative st, so it will leave behind only exponential negative st. So we're going to do this integrations of it. So integrations of this will give us 1 over s. Alright, 1 over s. So this will going to be our answer in S domain. Okay, the equation of ft in S domain. Right, so now let's look for the another example. Find the Laplace transform for ft is equals to 3 exponential 7t, where the t is larger or equals to 0. So we have to convert, since that they mention as Laplace transform, so meaning that our answer must be is in S domain, must be in S domain. So therefore we need to in order to find the f in S domain, we need to do the integrations of the ft equation. Alright, so ft equation, substitute with this equation. Alright, this ft we substitute with this equation, so therefore it will become 3 exponential 7t multiply with exponential negative st from the formula. Alright, so we can simplify this equation, since our 3 here is constant, so therefore we can bring the 3 in front, and then exponential negative s minus 7t dt. So integrations of this, we will get this equation. So by taking into considerations the limit, we will get our final answer as such. So this will gonna be our answer of the Laplace transform for this particular equation, right? Alright, so these are the Laplace function table that is actually included in your appendix. So please refer the complete Laplace table in your appendix. In your appendix, please refer it and make sure that you are familiar with the table. So usually they have a ft ft column, and also there is another column that is for the S domain column. Alright, so now we want to use the previous example, okay, that we have discussed previously. But in our previous example, we are using the equation. Yeah, we are using the equation, which is we are using this equation of Laplace t is equals to 0 to infinity ft exponential negative st dt. Alright, in order to obtain in S domain. Yeah, in order to obtain in S domain. So now we want to use another method, that is by using the table. Okay, that is by using the table that is given from your in your appendix. It will be provided in your appendix. Yeah, so we were going to use the same equation. So the first equation is ft is equals to t. So if we can draw the graph of of this, yeah, equation. So this is our ft, the y going to be our ft. So the graph we're going to look like such, right? We're going to have increased graph, yeah, increased graph like this, right? However, if we refer to the table, all right, if we refer or we can relate to the table, all the table that is provided to you, it is multiply, usually, yeah, it is multiply with ut. So what is ut? Ut is our if we can recall what we have learned in our chapter 1, it is a unit step. So general graph of unit step is usually it's going to look like this, right? Where at the positive side you're going to have a value of 1, and the negative side it will going to be 0. So if since that in your table it is usually multiplied with ut, so what is this mean? This means that this original graph is multiplied with a unit step. So therefore this negative part, yeah, so therefore this negative part will then can be eliminate, yeah, will be eliminate, and it will leave to us only the positive side of the graph. Yeah, it will only give to us the positive side of the graph. So this is called, so now our equation will going to be t ut. All right, t ut, and this is called as a unilateral. Yeah, okay, a unilateral function that we only consider one side of the graph, yeah, and we will not consider the negative side of the graph, yeah, because it is multiplied with the unit step, right? So now get back to these questions. So now we have ft is equals to t, and it is also can be written as, since that we only are considering the positive side, so therefore the t will be multiplied with tut. All right, so let's look based on the table which column that is relatable or looks similar with the equation given. Yeah, so we need to look at the table. So based on our reference from the table, we can see that number 5, yeah, column number 5 is the most similar to this equation, yeah, whereby the t and multiply with ut, you step, so this is in a t domain and this is in a s domain, yeah, and it will give to us the s domain is equals to n factorial over s n plus 1. So in this case, t here is actually equals to 1, yeah, t is our the power up here is actually equals to 1, so therefore we know our n is equals to 1. So since that we know our n is equals to 1, so therefore in the s domain it will be 1 factorial over s1 plus 1. So therefore it will gonna be 1 factorial over s squared. So 1 factorial is equals to 1. So therefore we will get our answer 1 over s squared. So you will get the same answer with the one that you have done before, which is that we are using this equation, right? So we can use both. Either you want to use the equation or you want to use the table. All right. So now let's look another equation. So another equation, ft is equals to exponential at. So same as before, this equation we will multiply with ut because we will only consider it from the positive side. Okay, so we will multiply with the unit step, yeah, exponential at ut, and we need to refer it from the table given which one that is similar, and based on our consideration from the table that is provided, we can see that column number 6 is much more similar to the one to the equation that is given to us. So therefore, if we want to convert into S domain, we need to identify, okay, we need to identify the value of this a here, yeah, a and a here. All right, so now let's make a comparison. Okay, so now we have EAT, but the equation that give to us exponential negative AT, right? So therefore, we know that the value of A here is actually equals to negative A, whereby E negative AT will give us positive value of this, right? Will give us positive value of this. So therefore, our A now is equals to negative A. So therefore, we can convert, yeah, the conversion of time domain for this equation into S domain, we will get 1 over S minus A. All right, S minus A. Okay, so this will be the answer. All right, so you will get the same answer as one that you have calculated earlier by using this equation, and the one that is that you use by referring the table. Okay, so now let's look another example. All right, so another example where it's given to us this equation. All right, so this is a unit step equation. So you know our unit step is already in a positive side, right? So we can use this equation, okay, the equations of Laplace, which is the integrations from 0 until infinity, multiply, the equation is multiplied with exponential negative s t dt, and we will get 1 over s, and we can also use the table. Okay, we can use the equation or you can use the table. So this is the first method, this is the second method, you will get the same answer. All right, so same as this equation. Okay, if we are using the equation, we will get the answer as such, 1 over s2, and if we are using the table, we will get the answer as such. We're supposed to get the answer as such. All right, so same goes to this equation and this equation. So there are two methods that you can use to solve your answer, to solve the equation in order to convert from time domain to S domain. Okay, first is you can use this equation, and the second one you can use by referring the table. All right, the Laplace table. Make sure that you are referring the right table. Yeah, it is Laplace transform table. Yeah. Okay, now let's try to solve another example. So find the Laplace transform for the following functions. So the first equation, it's given as ft is equals to t exponential 60. Alright, so now let's look let's use the table. Yeah, from the Laplace transform table, we can see the most similar. Okay, the most similar with the equation that is provided to us is column number 7. Okay, it's row number 7. Sorry, yeah, it is a row number 7 where the equation we need to identify the t and exponential negative at ut. So there are two variables that we need to identify, the value of n and the value of a. All right, where we will get our s supposed to be like this, right? So we need to identify the value of n and the value of a. We make a comparison with the equation that is given to us. So from the equation that is given to us, we can say that the value of n is equals to 1, and the value of a is actually equals to negative 6. So once we have identified these variables, we can just substitute inside this S domain equation. Alright, so we will get the answer in an S domain as such. Yeah. So for another example, it's given the equations of ft is equals to negative t sine 2t. Alright, so always bear in mind this equation must be always multiplied with ut. Although it is not written, it is always multiplied with ut. And if we can refer to the Laplace transform table, the most similar equation, the most similar row that is similar to the equation is row number 13. Alright, so now the variables that we need to identify is the value of a and the value of omega. Alright, so if we make the comparison now, the value of a is equals to 1 and the value of omega is equals to what? Is equals to 2. Yeah, is equals to 2. So once we have identified all of this variable, we can just substitute the value of omega and the value of a inside this equation, and we will get our final answer. Yeah. Alright, so now let's look for the another example, which is the example give to us, for example, example number 3, the equations here. T exponential 2t sine 3t, and we can see that based from this equation, it is actually a multiple component. They have a multiple component. Okay, they have a multiple component. Alright, multiple component inside this one equation. So if we can look in the Laplace transform table, there are a few possibilities. Yeah, there are a few possibilities that we can use in order to solve this particular equation. So the first one is the frequency shift, where we will assume that our exponential here will gonna be one equation. Okay, this will gonna be one equation, and another one, our ft will gonna be t sine 3t. Okay, our ft will gonna be equals to t sine 3t. Okay, because exponential is already in front here. Okay, so this is the first possibility. Another first possibility that we can choose is by using the modulation method. Okay, modulation method, because it is sine involved, where sine we're going to be as sine. Our ft now we're going to be t exponential 2t. Alright, okay, so these are the second possibilities, and let's look at our third possibilities that we can also apply in this equation. So our third possibilities is the multiplication by t, where t and ft, so therefore our ft will gonna be exponential 2t sine 3t. Okay, so now which one that we want to choose, the first one or the second one or the third one? Right, so always bear in mind, if there is a possibilities, yeah, if there is a lots of possibilities like this, okay, number 1, number 2, number 3, always bear in mind we will choose the simpler, we're going to choose the simpler combination. Okay, so how to decide the simpler combination? We need to look at the S domain. Okay, if you look at the S domain, this one is quite straightforward. We just need to find our f, okay, which is our ft, then we will convert it into our S domain, and then we just substitute into this equation and plus with a, right? That is for the first possibility. If we're going to use the modulation possibility, if we can see here, that is an involvement of j, which is the imaginary. So this is quite complex. Okay, the solution is quite complex. And for number 3, for possibilities of number 3, we can see here it will involve in our S domain, it will involve of what? It will involve of in differentiation. Yeah, it will involve of differentiation, and this is also complex. Yeah, this is also complex, so we don't want this complex to be involved in our calculation. So let's choose the simpler. So therefore the first one is much more simpler. We're going to choose this, yeah, instead of the rest. So please make a wise decision, okay, when you have a combinations or multiple component inside your equations. Yeah, list out the possibilities and then try to choose which one that has a simpler calculation or simpler combinations. Yeah, so therefore based on our judgment here, the first method is much more simpler, so we're going to use the first method. So we will decide that our ft is equals, this is our ft, yeah, this is our ft and this is our exponential. So exponential negative at f1t or ft, yeah, is equals to f1s plus a. So we need to know our f1. So our f1 is equals to t sine 3t. All right, so t sine 3t, if we look into the table, okay, we need to refer again the table, we will get the equations of in our s domain it will become 2 omega s squared plus omega squared and squared of it. Yeah, so therefore we need to identify the value of omega. So what is the value of omega now? Okay, our value of omega is equals to 3. Okay, and our t, since that this is power to 1 and this is also power to 1, so therefore we can use this one. Yeah, alright, so our omega is equals to 3, so we just substitute inside here with value of omega equals to 3, and then once we have got this, okay, once we got this, we substitute this value inside this equation. Okay, inside this equation, where this equation should be plus with a. So what is the value of a? A is equals to, this is the value of a is equals to negative 2. So negative 2 s plus a, it is s plus a, so s here should be plus a, s plus a, and this is also should be s plus a. Alright, so this is going to be our final answer. Alright, okay, now let's look in the inverse of the Laplace transform. So inverse of the Laplace transform, if we want to use the formula, okay, we're going to use the inversion of the S domain. So we need to multiply with 1 over 2 pi j, and the limits for the integration is negative j omega j infinity to j infinity, and the equation of S domain should be multiplied, okay, before the integration it should be multiplied with exponential st ds, and then only the operations of integration we're going to be take into solution. Yeah, so for example we have fs in S domain and we want to get back in our t domain. So how to use? So this is the first method by using the formula. However, there is always another method as previously. We can use the table. Okay, so if we want to use or we want to refer to the table, we're going to refer from the S domain into the t domain. So another way around. Yeah, just now is from the t domain we refer, from t domain we refer to S domain, right? So currently now we will refer, since that we want to obtain the t domain back, so we're going to refer from the S domain into the t domain. So we're going to look in our S domain which one has the most similar or look like the S equation. Yeah, so we will get the ft is equals to 10t ut. All right, 10t ut, and same goes to another this equation, and same goes to this equation. Yeah, so yeah, same goes to this equation. So for del, there is no multiplication with ut. If you can realize here, there's no multiplication with ut because of del t is it is just an impulse. Yeah, so it only involve of one side only. There is no like just now like this, there is a positive side and negative side, right? But then but for impulse it is only a one line like this, so it doesn't involve positive side and negative side, so therefore we don't have to multiply with the ut. Yeah, so now let's look another example for the inverse Laplace, where we need to determine the t domain. It's given as S domain. So given fs is equals to 3 over s squared, so what we need to do, we can always refer the table or using the equation. Okay, or using the equation. So by referring the table or by using the equation, you will get your answer as 3t. All right, so please try to approve this. Okay, please make your own calculation. Try to approve this answer, either this answer is correct or not. Yeah. All right, so now for the next equation, okay, it's given to us fs is equals to 1 over s plus 1, and gs is actually the s multiplied with fs. Okay, gs is actually s multiplied with fs, so this one is multiplied with s, so therefore our gs is equals to s over s plus 1. Yeah, s plus 1. So now we need to find the value of gt. All right, so please try to solve this, okay, by using the table or by using the equation. Okay, by using the equation or by using the table. So you should supposed to get gt is equals to 1 is del t and 1 is this one, yeah, exponential negative t ut. All right, so try to approve this by yourself. Alright, so now let's look for another example of the inverse Laplace transform. So given to us this equation 1 over s squared plus 25, and we need to determine the t domain. Okay, we need to determine the t domain. So let's use the method that by referring just a table. Yeah. So if we can see here, the equation now that is similar with the equation given to us based from the table is this, yeah, row number 9. Yeah, row number 9, where from here this down part, yeah, the denominator part is equals to s squared plus omega squared, right? This is given in the table, and the equation that is given to us s squared plus 25. So therefore we can rewrite that the equation actually is equals to s squared plus 5 squared. So straight away we can tell this, right? Straight away we can tell this. However, let's look at the denominator. Denominator for this equation is 1. However, in this equation, okay, based from the table, the denominator should be equals to 5. By right, it should be 5 over s squared plus 5 squared, right? But now the equation that is given to us, the numerator is only 1. Yeah, it's satu sahaja. There is only 1. So how to eliminate this 5? Okay, so therefore we need to eliminate this 5. So in order to eliminate this 5, we need to multiply with 1 over 5, right? We need to multiply 1 over 5. Therefore, okay, 1 over 5 is there. So therefore, it's going to be 1 over 5 sine 5t ut. Alright? Okay, so there's another equation. Determine ft, where the given equation is fs is equal to 2s over s squared plus 10. Alright? So if we look at the table, if we refer to the table, the equation, yeah, the similar equation is this equation, yeah, row number 8, cos omega t ut, where we can use this, yeah, s squared, and there is also s at denominator, and there is also the denominator, the s is also squared. Yeah, so how to use this? Okay, how to use this equation? So now we need to bring the 2 in front. Okay, we bring the 2 in front, so it's gonna be s squared plus 10, right? But now our omega should be squared as well. So how to do that? S over s squared plus square root of 10 squared. Square root of 10 squared, we will get 10 back, right? So we just add the square root, yeah, square root of 10, and we bring the 2 in front. So therefore this one, yeah, so this will gonna be cos, or our omega now is equals to square root of 10 t u t. Yeah, and don't forget the 2 in front here, 2 in front here. So therefore you will get this answer. Alright, that's all from me. Thank you very much. If you have any questions, you can just inform me or let me know. Yeah.